All right, so which one do we want to start with? Yeah, Emily.
21.
This is page what?
430.
Page 430, number 21. And I guess I probably...
4 parts, but...
You need all parts?
I feel like if we do one part, I can figure out the others.
Okay. Oh, yeah, it's the one that's involving?
Yeah. All right. I think there's a famous opportunity.
So someone was asking specifically for 21C, is that right?
Yes. That's what it looks like.
Okay, so we've got y squared equals 4x, and we have y equals x, and we're going to first get the bounded region. So y squared equals 4x is a sideways parabola. And y equals x. It's going to look like that. So our shaded region is here. And for part C, we are revolving around x equals 4. I think they hit at 4, right?
Yes.
So we're revolving around that. So then this is going to get rotated all the way over to here and back into the hallway, et cetera, et cetera. So since the rotation is happening this way, the circles could be seen from above. So you want to chop this way to get circular slices. And there's going to be a hole in the slices. So the formula then is pi integral big R squared minus little r squared because of the hole. And the height here is dy. So it's going to be a dy here. So I'm going to go ahead and solve for that intersection point. So that would be, if y equals x, I can put y in there for x. So y squared equals 4y. Just substitution into there. So y squared minus 4y equals 0. So y is 0 and 4. So there's the 0 y. So the shaded region goes from 0 to 4, up and down. So that would make this 0 to 4. So now we're to the hardest part, which are the radii. Okay, so the big radius is from here to there. So that distance. So the big radius has to do with the parabola. Then, if that point there is x comma y, that distance is x. This distance is 4. So this distance is 4 minus that x. So we've got pi integral from 0 to 4, 4 minus x squared minus. Totally good, Emily? Okay, then this point here is a different x comma y. So that distance is also x. So this distance is also 4 minus x. You sure with that? Okay. But this is the x on the parabola, and that's the x on the line, right? Okay, so now, last step is to replace this x with what it equals on the parabola, which is 1/4 y squared. So this is pi times integral from 0 to 4 of 4 minus 1/4 y squared squared minus, and then we have to replace this x with what it equals on the line, which is much easier, just y. So there's the setup for part C. Everybody okay with that? Are you sure? Okay, so what's next? Yes, Lydia. Not that we can't go over other parts of 21 if you want. Let's look at something different. So this is page 432, number 37. We've got this y-axis, this x-axis, this trough that has some water behind it. We're trying to find the fluid force on that water. Okay, so we use the formula, or it's not water, it's something else.
It's like big swamp.
Yeah, that it weighs, does it weigh 80 pounds per cubic feet? Okay, so we take that times the depth. So if this point right here is x comma y, then that distance is y. So, but the depth is from the top of the plate down. So this is a bit tricky because we usually chose our depth to be y. But when they put an x-axis and a y-axis in there, they chose what y was going to equal. So we can't have the depth be y, because y represents that distance. Okay, so knowing that, this is 2, if I remember correctly. So then this is y. So then the depth is 2 minus y. Is everybody okay with the depth being 2 minus y? This problem's throwing people off because we always labeled the depth y, which we had the power to do because we hadn't placed an x-axis and a y-axis on our picture. But they already placed the x-axis and the y-axis on this picture, so we didn't have the power to call that y because they already had called that y. Okay, so then you take 80 times the depth. Then you have to multiply by the area to get the force, right? But we need a little bitty area at that depth. And then we're going to add up all the different forces. Okay, so the area at that depth, well, the height is dy. And the width, well, if this point is x comma y, then that distance there is x. So the width of that rectangle is 2x, because this is symmetric. So the area is 2x dy. Feeling okay? All right, and then we'll integrate from 0 to 2. Because we're dy, so it's from the bottom to the top. Then the last thing we have to fix is we're not allowed to leave that x here, because we've got everything in terms of y. So what's the formula of this? Y equals x over 2, okay. So multiply both sides by 2, and you get what x equals. So this becomes the integral from 0 to 2 of 80 times 2 minus y times 2 times 2y dy. So I just replace that x with 2y because that's what x equals based on that formula. Everybody good with 37? Okay, what's next? Yes,
It comes up easy.
that's fine.
No, just hang on with it.
Okay, that's also fine.
We do 53.
So page 433, 53. So we've got, oh yeah, we got this region R. Got to find the area of it. Okay, so for part A, we're graphing 2 plus sine of x. Like that. Just took sine of x and moved it up 2. And then secant of x looks like this. Let's see, it goes through 0, so that's 1. So something like this. So you get this region R here. Maybe you didn't get that. Oh, secant is the, I was thinking it was the reciprocal of cosine. Secant is the reciprocal. Yeah, it is the reciprocal of cosine, but I was thinking it was the reciprocal of sine. Sorry. It's more like this.
Yeah, yeah.
Sorry. Thanks for looking at me like I was crazy. Okay, good. Now we got the right region R. So we got to find the area of that region. So we just draw rectangles in there and find the area of all those rectangles. The height of that rectangle is that y value minus that y value. So 2 plus sine of x minus the secant of x. Then the width of the rectangle is dx. But we have a lot of those rectangles, right, all next to each other, so we're going to add up infinitely many of those from this point to that point. So now we got to work on finding the intersection points between 2 plus sine x and secant x. I think this is calculator active, right? So it's fine to just, yes?
I think it was in quadrant 1.
Oh, they only want the area in quadrant 1. Oh, thank you. I didn't read the problem. That would be a good thing to do. So they just want 0 to whatever that intersection point is. Thanks, Tyler. So it's fine to graph this in y1 and graph that in y2 and then do second calculate intersect to find that intersection point. And I think it's like 1.29 or something. 1 point. And why are we not rounding to 3 decimal places there? Because we don't want to round in the middle of the problem, right? We need our final answer to be accurate to 3 decimal places. So we'll put more in just to be safe at that stage. Okay, so you're good with part A.
Yeah.
Okay, so then for part B, find the volume of that generated about the x-axis. Okay, so we're going to take this shaded region now and revolve it around the x-axis. So I better draw a new picture here. So this is going to revolve down to here. So we're going to get circles from the side. So we need to chop it this way to get circular cross sections. And those circular cross sections are going to look something like this. Do they have holes in them? Yeah, they do. Does everybody see that? Because you're revolving around this, so there's this space in here that it revolves around. Okay, so the volume formula is pi r squared minus r squared. and the height is dx. Doing okay? All right, so then we're down to the radii, which is the tricky part. Oh, this is still, since that's dx, this is still 0 to the 1.223. Okay, so then the big radius goes from here to there. Well, if that point right there is x comma y, that big radius is just the y of that point. So that's just 2 plus sine of x. And same thing with this point. X comma y, so that small radius is the y value on the secant. Okay, so then for part C, we've got our shaded region, again, region that they're calling R. And they are saying that this shape is the base of a solid. So this is the bottom of the 3D solid that they're talking about in C, because that region R is the base of the solid. So the solid is just up above this, somewhere in here. And then it says cross sections perpendicular to the x-axis. So what that means is if you cut it perpendicular to the x-axis, you get cross sections that look like squares. Because they say cross sections perpendicular to the x-axis are squares. So you cut it here and you got a square. So this is the bottom of one of those squares. And then the square comes out above this way. Because that's the bottom of the solid, and when you cut it, you get squares, so that's the side of the square. Then you'll cut it again, and you'll have a cracker, saltine cracker coming out of there above that. Is everybody visualizing okay? I can go over, still got the saltines over there if you want me to get it. You sure? Okay. Or if you're just hungry, I can get one too. All right, so there's that. So now the volume of that is side squared dx. And the side is just this y value minus that y value. So 2 plus sine of x minus secant of x. Are you okay with that? And then we're integrating from 0 to that same intersection point. Everybody doing okay on 53? Sometimes you feel like, oh, I'm at least now at a place where I could guess something to put down. Don't just get to that place. Get to the place where you actually know what's going on. Is everybody okay? Okay, what's next? Yes, Gabby. Sure. So 21D. So we had our sideways parabola and our line y equals x. And now we're rotating around y equals 4 for part D. So this is going to rotate up to here and then back through the hallway. So rotation this way, circles happening from the side, so we want to chop this way to get circular cross sections. Those circular cross sections are going to look like this. So, and it has a hole in it. So it's pi r squared minus r squared, and it's dx. So then the larger radius has to do with the line. If that point is x comma y, that distance is y. So this distance is 4 minus that y. So I'm saying 4 minus the y of the line here. And then the smaller radius has to do with the curve, or the parabola. This distance is the y of the parabola. So that distance is 4 minus y of the parabola. I think we know this point's 0, 0. And is that point 4, 4? So now we're going 0 to 4. On part C, we went 0 to 4, right? Now we're going this 0 to that 4. Because it's dx. And then we need a formula for this. Well, the y of the line is just x. And the y of the curve is the square root of 4x, is that right? Yeah. All right, what's next? Yes, Emma.
Just part B on 54, the rest is,
So 54B. They want to know when the temperature is greater than or equal to 78, right? F of T is the temperature formula. So they want to know when F of T is bigger than or equal to 78. So then they want, I better look at what F of T is. 80 minus 10 cosine of pi t over 12 greater than or equal to 78. So whenever you're solving an inequality, you have to figure out the equality first. Because those are the places where it might switch from positive to negative. Excuse me. And technically, we have to check for this being undefined as well. but it's never undefined. Okay, so then you subtract the 80, and you get negative 10 cosine of pi over 12t equals negative 2. Then you divide by the negative 10. Okay, so now we're looking for an angle that has a cosine of 1/5. This says the cosine of whatever angle is 1/5. So if we were on the unit circle, that would mean that the x value would need to be 1/5. None of our unit circle memorized points have that x value being 1/5. So that means this is a calculator active question. So we're looking for the angle that has a cosine of 1/5. So the way to find that is to do the inverse cosine of 1/5. So you just type in inverse cosine of 1/5. And I think you get 1.39. I need more digits. Sorry, start from the beginning. 1.3694. Give me a couple more. Just because I'm scared to round in the middle of the problem because I need my 3 decimals to be accurate at the end. Okay, now that's what this angle is here. That angle is 1.369 radians. Okay, the problem is there's another angle that has that cosine. In the 4th quadrant, the x value could also be positive 1/5. So that means that we have to now get this other angle. Well, it's just negative 1.369, but we can't use that one because our range is 0 to 24. So we need a different name for this angle besides negative 1.369. So the way you get that,
Global media auditions have been rescheduled to Tuesday, February 16th after school.
the way you get that is you
Mr.
take
Kim,
2 pi minus that.
if you need more information about global media, thank you.
Then to finish out the problem, you'd multiply by 12 and divide by pi. And then you'd have your t values, right? You guys can go, it's not a problem.
Could please go to the main office, Madeline Smith?
So then you have a couple of t values. And then you test these intervals to see when it's positive, when it's negative. That's how you solve an inequality. You find the cutoff values and then test the interval. Good. So just to finish this up for the video. Yeah, we're turning in the review, please.
Will you be lecturing for me?
Gabby.
7th?
Gabby.
Yeah, 7th is calc,
Oh, I mean 6th, sorry.
not 6th.
Okay.
So this is 5.231. And then you just test those intervals. We're going to